Welcome to a webinar organized by the EU-funded IMPRESS project, focusing on finding ways to produce sustainable chemicals and materials. Our webinar is titled Life Cycle Assessment: Your Path to Sustainability. My name is Stanislava Petrova, and I'll be your host for today. The IMPRESS project was launched in September 2019, and it aims to create a new hybrid biorefinery process. This means researching and combining selected key technologies and using them to refine renewable resources, such as forestry and agricultural residues, into multiple sustainable chemicals and materials that can replace fossil-based products. The IMPRESS consortium consists of 10 partners around Europe and is led by Avantium from the Netherlands. Our first webinar introduced the consortium, concept, and a bigger chain reaction that it is a part of. In our second webinar, we gave a closer look at the high-value plant-based products resulting from the IMPRESS project. If you missed any of these, you can find them on our web pages. This third webinar is a series of 4. Today, Sphera will introduce you to life cycle assessment process and present the IMPRESS concept LCA. However, before going deeper into the LCA, first on our agenda is the introduction to sustainability, presented by Rahel Afzal from Sphera. After that, Rahel is also going to give you 2 more presentations about the LCA itself. Finally, you get a glimpse into LCA online tool, presented by Joshua Morshead from Sphera. But first, Rahel, please.
Hello and a warm welcome to this presentation on LCA as part of the IMPRESS webinar series. A quick introduction to myself. My name is Dr. Rahel Afzal, a senior consultant working at Sphera. The format of the presentation will be a running commentary in the background whilst the slides are presented. I hope you enjoyed this presentation and take something with you. In this section, I'll be introducing the topic of sustainability, business drivers, and then specifically how Sphera can help you on your path towards sustainability. Now, what do we mean by sustainability? According to the United Nations Brundtland Commission, sustainability can be defined as meeting the needs of the present without compromising the ability of future generations to meet their own needs. In the context of climate change, this usually means changing our energy, transportation, and other systems so that they don't contribute to warming the planet. According to the Intergovernmental Panel on Climate Change, also known as IPCC, Special Report on Global Warming, human-caused emissions of carbon dioxide need to fall 45% from 2010 levels by 2030 and reach net zero by 2050 to limit climate change catastrophe. Now, this is particularly challenging in the current economic and global crises currently ongoing. Yet we can overcome these obstacles in time if we take responsibility and act decisively. Tackling sustainability reduces exposure to environmental risk, increases revenue through innovation, decreases costs with greater efficiencies, and drives organizations into a more sustainable future. So, what are these business drivers for sustainability?
Now, there are 4 main business drivers illustrated on this slide. But before these are explained in detail, a few terms need to be defined. The terms ESG and sustainability are used interchangeably, especially when it comes to benchmarking and disclosing data. Sustainability is an umbrella term for many green concepts and corporate responsibility, whilst environmental, social, and governance (ESG) has become the preferred term for investors and the capital markets. Investors are increasingly focused on climate and ESG-related disclosures and investments. Companies with strong ESG performance have higher returns on their investments, lower risks, and better resiliency during a crisis. Explaining the business drivers from the top left, net zero refers to the balance between the amount of greenhouse gas produced and the amount removed from the atmosphere. It is now widely accepted that there is an urgent need to accelerate the transition towards global net zero emissions. More countries and companies are making public commitments to be net zero on a specific timeline. For example, whilst the 2070 target date for India's net zero commitment have made headlines, the shorter-term commitments to generate 50% of India's power from renewable sources by 2030 and commit to a 45% reduction in carbon intensity of their economy is a meaningful shift. Other examples are the two largest economies in the world, the United States of America and China, strengthening their cooperation on climate action. In the bottom left, we have evolving global and regional regulations. Examples of a few of these include the European Green Deal. This presents a roadmap for making the EU's economy sustainable by turning climate and environmental challenges into opportunities across all policy areas and making the transition just and inclusive for all. The European Green Deal aims to boost the efficient use of resources by moving to a clean, circular economy and stopping climate change, reverting biodiversity loss, and cutting pollution. It outlines investments needed and financing tools available and explains how to ensure a just and inclusive transition. Related to this is the EU taxonomy. This is a classification system establishing a list of environmentally sustainable economic activities. The EU taxonomy is an important enabler to scale up sustainable investment and to implement the European Green Deal. Lastly, are carbon taxes. A carbon tax is an important tool in trying to price the true cost of products that have an impact on our climate. Many economic commentators believe it is the most effective economic tool for reducing greenhouse gas emissions. The idea of an EU carbon tax is economically sound and could, if set at the right level, be a hugely important instrument for reducing emissions. However, there might be difficulties getting it approved. Tax policy is an area where any EU decisions require a unanimous decision amongst member states in Council. In the top right, we have pressure from financial markets to disclose ESG data. An example of this are institutional investors like BlackRock and PIMCO-backed Climate Action 100 Plus are intensifying push for net zero emissions at companies they hold. The pressure from the markets is largely due to three factors. Number one, global regulatory and policy shifts. As governments seek to meet climate and sustainability goals, they are turning up the pressure on companies to account for their own impact. Number two, lack of trust in ESG data. Whether companies have just begun reporting ESG data or have been doing it for years, this puts pressure on them to invest even more in the process. And lastly, long-term capital focus on ESG. In the bottom right, we have the last business driver, which is consumer preferences. Consumers are not just looking at products anymore, they are choosing brands that have environmentally sustainable or more ethical practices and values. In addition to this, consumer spending habits are also changing. An example of this is 74% of consumers are willing to pay more for sustainable packaging. So how can businesses navigate through these challenges? This is where Sphera fits in. Sphera is a leading provider of environmental, social, and governance performance and risk management software, data and consulting services with a focus on environment, health, safety and sustainability, operational risk management, and product stewardship. Discussing each of these topics highlighted in blue, orange, and green respectively. Firstly, in terms of environment, health, safety, and sustainability, despite constant changes, leaders have to make sure employees and the environment are protected while maintaining operations, remaining compliant, managing regulatory changes, and improving sustainability. Powered by Sphera Cloud, our enterprise EHS software solutions combine a responsive, configurable, and intuitive cloud-based platform with world-class content. Our deep domain and industry expertise enable better decisions and optimized performance. In terms of operational risk management, operators with digital vision are innovating at scale and demanding solutions that can help them keep pace. They are looking for simplified, standardized processes and improved visibility to establish an environment of collaboration, streamlined operations, and a dynamic, accurate understanding of plant conditions. Our operational risk management solutions enable operators to establish a unified strategy for their control of work, risk assessment, and master data management processes. Lastly, in terms of product stewardship, even the most experienced teams can be overwhelmed by the array of regulations that impact their ability to create and deliver new products, attract new customers, and capture new markets. Taking control of chemical management, product compliance, and product sustainability enhances safety and improves performance of both products and the bottom line. Our award-winning product stewardship software combines best of both software tools with broad and deep content and a team of experienced professionals to create an optimized approach to product stewardship. We believe that being able to excel in all three areas buys a company's reputation and productivity. Doing so is not just the right thing to do, but it's a smart thing to do. Businesses that become ESG leaders see better bottom line results as well. Having discussed this on a macroscopic level, if we delve deeper, how is value created? Creating value through sustainability is an iterative process consisting of 4 stages as shown in the slide. Stage 1, identify and strategize, focuses on developing a successful sustainable strategy. Stage 2, quantify and improve, focuses on firstly quantifying your baseline and then identifying opportunities for a sustainable future. Stage 3, implement and monitor, focuses on utilizing data and technology to not only monitor and maintain, but also keep a track of your progress. And lastly, stage 4, inform and reporting, is translating the finding of a particular study to investors, consumers, and the public. There are a number of services Sphera offers. If interested in any, please do get in touch. But in the meantime, I will explain a few. Lifecycle assessment is one of these. LCA enables an organization to analyze the entire lifecycle of their products and services with regards to their environmental impacts and to display the results in a transparent way. Product carbon footprint, or PCF, sums up the total greenhouse gas emissions generated by a product over the different stages of its life cycle. Portfolio sustainability assessment provides companies with the insight to classify their product portfolio into performance categories, identifying both high-performance product market combinations and challenging ones from both a sustainability perspective and an operational perspective. Companies who have adopted PSA methods indicate that improved sustainability performance has resulted in tangible business benefits, such as better decisions, more robust strategies, higher growth rates for more sustainable solutions, stronger customer stakeholder relationships, reduced risk, and an improved corporate image. Lastly, EPDs, also known as Environmental Product Declaration, is a document which transparently communicates the environmental performance or impact of any product or material over its lifetime. Within the construction industry, EPDs support carbon emission reduction by making it possible to compare the impacts of different materials and products in order to select the most sustainable option. An EPD is usually valid for 5 years and is generated according to the relevant standards, normally EN 15804. EPDs also help to achieve EPD and LCA credits in certification schemes like LEED, BREEAM, and others. Whilst we offer these services, it is our trusted GaBi software that a lot of organizations and individuals are also interested in. GaBi is the most trusted product sustainable solution for lifecycle assessment with over 10,000 users, including Fortune 500 companies, leading industry associations, and innovative SMEs. GaBi models every element of a product or system from a lifecycle perspective, equipping businesses to make the best informed decisions on the manufacture and lifecycle of any product, everything from a mobile phone to a matchstick to an airport. It also provides an easily accessible and constantly refreshed content database that details the cost, energy, and environmental impact of sourcing and refining every raw material or process component of a manufactured item. In addition, it looks at the impact on the environment, presenting alternative options for manufacturing, distribution, recyclability, pollution, and sustainability. GaBi makes it easy for businesses to carry out lifecycle assessments in order to protect their most precious asset, their brand. He also enables them to deliver more sustainable yet cost-effective products that better satisfy consumer expectations. For any inquiries, please do get in touch with myself. This ends the introduction to sustainability section. The next section focuses on LCA methodology. Welcome to the second part of this presentation, which explains LCA methodology. However, before detailing the method, it is useful to explain life cycle thinking.
Life cycle thinking is about going beyond the traditional focus on production side and manufacturing processes to include environmental, social, and economic impacts of a product over its entire life cycle. The main goals of life cycle thinking are to reduce a product's resource use and emissions to the environment, as well as improve its socio-economic performance through its life cycle. This may facilitate links between the economic, social, and environmental dimensions within an organization and through its entire value chain. However, life cycle thinking in itself is not just applicable, there need to be some standards. Standardized by the International Organization for Standardization (ISO), the leading standards for life cycle assessment are ISO 14040 and ISO 14044. They can be defined as follows. ISO 14040 Principles and Framework provides a clear overview of the practice, applications, and limitations of LCA to a broad range of potential users and stakeholders, including those with a limited knowledge of life cycle assessment. ISO 14044 Requirements and Guidelines is designed for the preparation of, conduct of, and critical review of life cycle inventory analysis. It also provides guidance on the impact assessment phase of LCA and on the interpretation of LCA results, as well as the nature and quality of the data collected. The standards lead us onto the methodology.
According to the ISO 14040, the execution of an LCA is divided into 4 stages, namely goal and scope definition, inventory analysis, impact assessment, and interpretation. The following slides give an in-depth overview of each stage. The goal describes the reason for executing the LCA study and also ensures that it is performed consistently. Goal definitions can include why is the study being conducted, who is the primary target audience for the study, and how does the intended application of the study relate to these goals, values, and principles. The scope provides a precise definition of the product and its life cycle and a description of the system boundaries. Terms to understand here are functional unit and system boundary. Functional units are foundational to LCA as they enable objective comparisons across different products or systems that serve the same final function. System boundaries are normally defined as boundaries for which processes in the product's lifecycle that is included in the LCA. Once the goal and scope have been defined, the next stage is to conduct an inventory analysis. The inventory analysis stage primarily focuses on data collection. The data collection in a study generally consists of the following parts according to ISO 14044. Preparing for data collection, validation of collected data, and allocation. Data collection is normally conducted via a data collection template. The template allows detailed tracking of all the flows in and out of the product system, including raw resources or materials, energy by type, water, and emissions to air, water, and land by specific substance. The data collection should also align with the scope of the study. This slide depicts the more common life cycle stages assessed. These can be defined as the following. Cradle to grave is the full life cycle assessment from resource extraction to use phase and disposal phase. Cradle to gate is an assessment of a partial product life cycle from resource extraction to the factory gate. And gate to gate can be defined as a partial LCA looking at only one value-added process in the entire production chain. You can also have cradle to cradle, which is a specific kind of cradle to grave assessment where the end-of-life disposal step for the product is a recycling process. Once the data has been collected and validated, the potential environmental impacts of the system are assessed. In the life cycle impact assessment stage, LCI results are associated to environmental impact categories and indicators. According to ISO 14040, the impact assessment are divided into the following mandatory and optional elements. Mandatory elements include selection of impact categories, category indicators, and characterization models, classification, and characterization. There are also optional steps for LCIA, including relating the impact indicators to reference conditions known as normalization, grouping, and weighting impacts. Currently, most LCIAs only perform the 3 mandatory steps. The next 2 slides detail these. The following slide details a few of the main impact categories normally used. This is not an extensive list, and there are other categories available such as ecotoxicity, human toxicity, water and land use, and resources to name a few. However, once the impact categories have been selected, they then undergo a classification and characterization step. In the classification, the input and output flows from the inventory are classified and grouped according to type of environmental impact, i.e. the impact categories. In the characterization, the input and output flows from the inventory are used to calculate the result for the category indicators. Emissions can be assigned to one or several impacts. For example, CO2 is assigned to global warming, and NOx is assigned to both acidification and eutrophication. The contribution from each input and output in the product system are then aggregated into a total for each category indicator. However, there are a number of different methods, e.g. Tracy, CML, Recipe, available to conduct an impact assessment. A company wishing to market its product as environmentally friendly in several member state markets then faces a confusing range of choices of methods and initiatives. Sometimes they have to use different methods for different markets. This results in cost for companies and confusion for consumers. Therefore, the European Commission have established a common methodological approach for quantifying the environmental performance of any good or service throughout its life cycle, called the environmental footprint (EF). There are 16 environmental impact categories defined in the third edition of the EF methodology. This details all the impact categories required, which mitigates confusion about selection of categories whilst allowing for a consistent approach. Now, the final thing to discuss as part of the impact assessment is allocation. In reality, many processes yield more than one product. The challenge is to assign the right amount of all resources consumed and emissions caused by a process to the right product. This is addressed in LCA through allocation. The allocation method can be via mass, energy, or economic. Normally, the issue of allocation will get picked up in stage 1 where the goal and scope are being defined, as well as in stage 2 when data is being sought. Once the impact assessment is done, the final stage of the LCA is interpretation. The aim of the interpretation stage is to reach conclusions and recommendations in accordance with the defined goal and scope of the study. In practice, though, each result from the different part of the study is interpreted separately. For example, in the inventory stage, issues such as data used for included unit processes, system boundaries, the decisions regarding inclusion and exclusion of processes, consequences of cutoff. In the inventory result, which parts of the product system have a large contribution to the overall result, and where can improvement potentials be identified. Issues can also be identified in the impact assessment, specifically the classification and characterization. For example, which flows and paths in the system have a large contribution to the impact assessment result for the selected impact categories. Thus, significant issues can be identified for each intermediate result in the study. Evaluations are performed with regards to completeness, sensitivity, and consistency for each result separately, and are then combined into an overall evaluation for the full study. Once the study has been evaluated, The last stage is making sure the work is effectively reported and communicated. Reporting and communicating are important elements in making understandable, transparent, and reproducible lifecycle assessment studies. Reporting is also essential in explaining LCA to non-LCA experts, as well as getting buy-in from investors, shareholders, and the general public. Although not mandatory, some studies require a critical review. A critical review is an important element of an LCA study that helps ensure conformance to the relevant LCA standards, ISO 14040 and 14044, and thus build credibility and trust in its methodology, data, results, the robustness of its conclusions, and ultimately increasing its acceptance among stakeholders. Once a review, if selected, is complete, this normally signifies the end of an LCA study. Although LCA studies are useful, they have their limitations. They cannot assess any and all relevant environmental issues. They cannot predict actual or precise environmental impacts. They cannot predict the exceeding of threshold safety margins or risks, and they cannot predict market responses to changes in production and consumption. This ends the section on LCA methodology. The next section will describe LCA within the IMPRESS project.
Welcome to the third part of this presentation, which explains LCA within the IMPRESS project. WP5 refers to Work Package 5, which are all tasks assigned specifically to Sphera. These are shown in more detail in the following slides. When successful, the proposed IMPRESS technologies will enable increased productivity, purity, and quality of end products. The objective of WP5 is to prove the proposed IMPRESS technologies will additionally lower the process environmental footprint and increase the overall resource and energy efficiency. This slide details the breakdown of Work Package 5 into a series of tasks to be completed by Sphera with contribution exchanges with a number of other project partners involved. The following slides provide a brief overview of each task. Task 5.1 centers on the establishment of LCI datasets for benchmark compounds, the majority of which are illustrated on this slide and can also be found on the IMPRESS website. Literature and patent research will be conducted on the production of these benchmark compounds. Once enough data has been gathered and validated, models of these materials in GaBi will be established according to ISO standards and ILCD documentation. ILCD refers to the International Lifecycle Data System. Similarly to Task 5.1, Task 5.2 focuses on the establishment of LCI datasets for European wood feedstocks. The approach is similar to before in that initially a literature review will be conducted in order to gather and validate suitable data to be used. Once this has been done, models of these materials in the LCA software GaBi will be established according to ISO standards and ILCD documentation. Task 5.3 is probably the most challenging in terms of collecting LCA data from several different project partners on different compounds and processes. Data collection templates will be utilized to collect most of the data, with some stages of clarifications potentially required. Sphera will work closely with project partners on data sources and assumptions. Once the data has been collected and validated, the initial task would be to build a parameterized model in GaBi for each unit process, with the final step being to integrate all the unit processes in the final model. Once the GaBi model has been built, parameterized, and integrated, Task 5.4 centers on the development of an online scenario modeling tool through a web-based software tool called GaBi Envision. GaBi Envision enables the user to quickly understand and communicate the sustainability performance of their products and compare alternative product designs without the need to be an LCA expert. Once an LCA is modeled in the GaBi software, simply import the file into GaBi Envision. In this intuitive web application, you can easily use and change parameters of your models and thus compare different scenarios of your product design. Then simply with the push of a button, create and export your LCA report in your corporate design as a PDF or RTF file. GaBi InVision easily integrates lifecycle assessments, environmental product declarations, or any kind of environmental footprinting into your internal processes, quickly evaluates what-if scenarios, and communicates effectively using standardizable reports. The following slide provides a screenshot of the GaBi InVision tool and shows the functionality of it, which will be demonstrated later on in a live tutorial. The final task, 5.5, will focus on a comparative lifecycle impact assessment of compounds produced using benchmark processes and impress processes. The comparison will be based on ISO standards and applying CML and/or PEF indicators, with the end deliverable being an ISO-compliant report. The main deliverables of the project will be the establishment of LCI datasets for benchmark compounds, the establishment of baseline LCI datasets for impressed compounds and processes, the development of an online scenario modeling tool, as well as the e-learning module of Principles of LCA. Other related outcomes will be the online documentation of LCA work impress project, and then any publications or conference presentations as a result of this work.
Thank you, Rahel, for your excellent presentation. Our final presentation will introduce you to the LCA online tool in practice. Joshua, go ahead.
Hello and welcome. Thank you for taking the time to see a demo of the GaBi packaging calculator that's offered by Sphera. I am Joshua Morshed, the account executive that handles this software, at least in the Nordic region of Europe, and I'll be giving you a presentation today to give you an idea about what this is for a tool, how it's commonly used, what are the concepts behind it, and also we'll be spending time actually in the tool itself, just so that we can click through it and you can actually see what it looks like in practice. So hopefully this will be helpful to give you an overview. It's just a 15-minute introduction. So I hope that gives you at least the first impression of what we offer here. So if we go into just the initial introduction, it's a packaging calculator. So it's essentially designed to help our customers to calculate the carbon footprint or even the total environmental footprint for any type of packaging. There is no expertise required to use this particular tool. It is based on an LCA that is doing the calculations behind the scenes, but for the front end user interface, anybody can use it. It's very easy to use. There's no training involved. So it is an LCA calculation, but it's very light on the user in terms of their experience. It's a web-based online application, so it sits in a browser offered by, if it's Chrome or any of the or Microsoft Edge, whatever you're using. We're very flexible there. It is using the GaBi database behind the scenes that are part of that LCA model. The results can be created very easily by entering values in fields that I'll show you in a moment to represent the quantities of different types of materials. And then just by clicking on the calculate button, the results can be then seen in real time. So there is a report that is representing the entire LCA results, and that sits next to the dashboard where you can enter the different values and create the scenarios for different types of packaging. So essentially you can create the scenario for a packaging type here, hit the results button, and then you see that full LCA results immediately. So this is just really designed to speed up those calculations for different types of packaging without having to dive into building an entire model every time. All of that model has already been done, and those options for different materials are offered as parameters within this user interface here. So the concepts of how this actually works is basically we have already created that model, which is sitting behind the scenes. That is used as a calculation engine. It's based on our well-recognized GaBi LCA software, and that model contains parameters for many, many different types of packaging materials, different types of manufacturing processes, transport routes, energy sources, and they're all set up as parameters within that model. So that's a really fully loaded model on the back end. And those parameters can then be manipulated within the packaging calculator. And that's used on the customer end, okay? So we've done the heavy lifting with building that model so that our customers can simply just get in there and adjust those parameters and build out the scenarios for their particular type of packaging. The idea is that these are scenarios that are often used at the eco-design stage. So they're helping customers to work out what would be the impact of using a bio-based plastic versus a regular plastic, for example, or what would be the impact if we switch to bio-based laminates or any other type of material at all. So it's kind of those what-if scenarios, helping product designers and packaging designers to think outside the box and see what would be the environmental impact of using different manufacturing materials, but even different manufacturing sites. Like if you simply change the energy grid mix that is flowing into a manufacturing step within that model, then suddenly that model would be calculated as if it was that packaging was manufactured at a different location in a different country even. So it's possible to then create these different scenarios and create a full report for what would be the environmental impact. That report can then be used internally, also externally to communicate those results and really just to put some weight behind those conversations internally, especially with your colleagues, to convince possibly the purchasing manager to open up budget for the more sustainable material. It does cost more, but it actually reduces the carbon footprint of that packaging. And if that is also a corporate goal, then it would also be recognized. But this gives that conversation the statistics and the metrics to be able to show what would be the value of changing to a more sustainable packaging type. So essentially this works as a user interface where the user can select the different materials that are in their packaging and the processes that are involved. It's simply a matter of filling in the values into the different fields according to the different materials that are relevant for that particular packaging type, defining any transport routes that are known, and then hitting the calculate button, and that result is then created in real time. That report can also be exported as a PDF or RTF. So depending on the particular use case, it's very flexible. The report can also be customized with the customer's logo and corporate image, just to make that extra difference, especially if it's going to be a customer-facing document. So this is just a screenshot here of the tool, which I'm going to dive into in a moment. It allows you to play with these parameters. And these parameters have been set up in that back-end model, and they allow the user to then choose, just in this example here, we can see plastics. We can choose, first of all, the mass of plastic. So we're selecting the quantity of that material, and then choosing the material itself. And there is a very wide range of different plastic types here. Here we can just see the standard plastics. We also have another drop-down option for bioplastics, for example. Then we have that list as well. And so basically, in terms of the user experience, this is all there is. It's just a matter of entering values here and hitting the calculate button to create a scenario. So we'll have here, in this case, we'll have two scenarios that we're calculating. A baseline scenario, this might be the packaging as it is today, and then the alternative scenario. So we can see two alternative scenarios side by side. This might be the alternative for the type of packaging that you're thinking of using in the future, and to essentially help you to calculate what would be the carbon footprint or the environmental footprint of that alternative before it goes into production. In this case, we can also choose the region of manufacturing. The baseline, the initial version is created within the EU. That means that we have the energy grid mix coming from an EU country. And the alternative is if we were manufacturing that material in the United States, then we would be taking a different energy grid mix. And those are all set up. These parameters are all coming from that back-end model that has already been created for you. So this is just a view to show how those parameters can be controlled by entering values in the fields on that left-hand side of the screen. Then on the right-hand side, you can see a preview of the report. It's the full report. It's quite a long, extensive report as well. It can be up to 20 or 30 pages, depending on the complexity of your packaging. And that is then available to see as a preview and then also exported for sharing. At this point, I'll just also switch over into the software and give you a look at what this all looks like in practice. So at the top, we have 3 tabs. The first one is just the global settings. This is where you set the 2 values that form the basis of your whole analysis. So especially if you want to compare 2 alternative types of packaging, it's important to use a unit of assessment that is most meaningful to the question at hand. For a consumer, a single consumer package might be the most likely functional unit that would be used, but then for manufacturers, it may be more meaningful to assess a full shipment of packages or tons of product content, both with a representative amount of packaging. So therefore, these 2 values really need to represent what you want to calculate. In this case, we're looking at primary packaging, and the number of assessment units would be 1. So that can be changed at any time. We're looking at packaging in terms of primary packaging, secondary, and tertiary. So if it's primary packaging, that will be, for an example, if we have a bag of chocolates, each individual chocolate will be wrapped in its own wrapper. Those chocolates will be coming in, maybe 20 of them in a bag. So that would be the secondary packaging. And then the tertiary packaging would be perhaps a box of those bags of chocolates that would be delivered wholesale to the supermarket. It can also be set up differently depending on your needs. We also have tertiary packaging options for pallets and crates with all their strapping and nails and screws as well. So it depends how extensive you want to go. If we go to the second tab, we can see the text variables. This is really just how you can customize the report that comes out of the after you've done your calculation. So that's where you can customize who is prepared the report. You can put your name on here, the author, and essentially just put your company name on there and just sort of customize the results a little bit. Then in the third tab, that's where we really get into the heart of the tool. I'll just make this a little bit easy to look at. And that is where we have, first of all, the general overview at the top. This is, here we can see the baseline and the alternative scenarios that we're comparing side by side here. This is essentially where you would do possibly benchmarking of 2 different packaging types. Perhaps you are looking at switching to an alternative type of packaging, in which case you would set the existing packaging here as a baseline. The alternative is the other scenario here. Otherwise, if you're just calculating the environmental footprint of one type of packaging, you would simply leave one entire column blank and simply enter the fields, the values in the fields of that alternative. And then essentially the tool calculates based on whatever values have been entered in these fields. So for that primary packaging, If we go into the options here for primary packaging, here we can see the different material options. First of all, we have plastics. Then we have an entirely separate category for bioplastics. That's an expanding category these days. We have all laminates in there, also glasses, metals, also natural materials, and also foams. We can look into those in just a moment, but just to show you the structure for what this looks like, basically what we can do is we can open this up. Within the primary packaging alone, we have 3 different options for 3 different types of plastics. So this is presuming there are 3 types of plastics just within the primary packaging. And that's very common these days as packaging is becoming more complex. So if we choose just one of those packaging options, here we have the drop-down menu. So basically, we're choosing the mass of material, how much of the material is in that first primary packaging, in that first type of plastic involved. And then just by clicking on this drop-down menu, we have the different options for different types of plastic. We might want to compare a PET to polypropylene, for example. Then we'd have that model as the baseline, which is the PET, and we're thinking about using polypropylene as the new type of packaging. Compounding, this is where you might want to include anything like different types of granulates or fillers or dyes that are involved here. That's a simple yes or no option if there is a compounding step involved. And then there is the manufacturing step. So what type of manufacturing is involved in preparing this packaging type. Then you can also select the recycled content if you have that information, and if that's relevant, then you can enter that here. And then finally, you can also select the transport method to the packaging site. So this, whether it's air, rail, road, or sea, it's simply a matter of entering the kilometers via each transport modality. And those are then, of course, calculated back to the back in the model. So we have the different diesel mixes for the different types of, or the different heavy fuel or whatever is going into those transport options. And that is essentially what we're calculating at that high level. We can then go into the different types of bioplastics. Again, it follows the same structure as what we saw. However, there is a slightly larger list of different types of bioplastics. I'll just scroll through them slowly. A lot of different options here, becoming very popular and in high demand from our customers. Just to see if we actually have all of those new innovative types of materials. The answer is yes, we have most of them. It's also worth mentioning here that if there's any type of material that you require that's not found in this standard version of the packaging calculator, we can also customize this and set up a customized version for you that best represents your particular packaging. So that's also possible. The laminates is a bit different. This is where you can actually select the adhesives that are involved, that are used. And there's also a lot of different types of foils as well. So if we just choose that one type of foil, for example, it requires the user to enter the thickness of that material. And essentially the adhesive, this is what I mentioned just a minute ago. So you're choosing the quantity of material in terms of mass, the adhesive that's used, and if there's any solvents used as well. So essentially, the laminate comes with everything that's required, including within that laminate to attach it to the packaging. The glass and the metals are more straightforward. This is just a question of the percentage of recycled content. So if for steel, you can see the type of recycling content, also the mass of metal. You can choose the type of metal, of course, depending on what you're using. Natural materials, this is where you've got all your fibers and your different types of pulps and cardboards and cellophane and everything, cork, cotton, jute, wood. So this is that's where you would find those options. And essentially, in terms of the actual calculation that's done, you can enter your materials at any point and they will be included in that calculation. The foams, that is not relevant to all types of products, mostly used for electronic products. But again, we've got the different types of foams in here as well, always including the recycled content if that is relevant. So I'm just going through the different options here, and that is the primary packaging. Now, the secondary packaging follows the same structure. So that is the same again, just if you've got a secondary display packaging, for example, compared to the consumer packaging, which the customer actually unpacks themselves. And then there is the tertiary packaging. This is a bit more unique. This is where you've got all of your screws and nails and other whatever else that you're using. If you've got lashing involved, or if you've got crates that you're using, we can also model the reuse of any crates and pallets as well. Often they are reused. With the natural materials, that's where you can enter different types of board, also the wood as well. If you're looking at pellets, and then finally, just coming down to the reuse stage, if there is any reuse, we're looking then at the how many cycles, how many times is that packaging being reused? So collected, recycled, cleaned, and reused in another packaging. Also relevant at this stage is transporting the transport distance. So any steps involved in the downstream of that packaging. So to pick it up, have it recycled and cleaned and prepared for the next round with the customers. So that's essentially calculating all of that transport distance there, because that also does contribute to the carbon footprint. And then finally, with the end of life, we go back through each of those materials again and look at where they're ending up with in their end of life. So if it's going into landfill, incineration, or recycling. Okay. So once you've entered your values in those fields that we just looked at, then you would hit this calculate button, and then all of those values that you've just entered will come up here. And that is where we have, at the moment, we have all those factors behind the scenes being calculated within that larger model. I have not changed too much here as I went along. First of all, we can see the results that can be seen in two options. First, you can see just the tables and charts. So that sort of just focuses your attention just on the actual results section, or we can show the entire full report, which is presented as a PDF in this case. So you can scroll through the entire very long report and understand exactly what has been calculated, what was in the back-end model. I'll show you that in just a moment. If we look at the options for these for the tables and charts, we can see that there is actually, for example, within the EF 3.0, that's one of the LCA methodologies that we can use here. We can see those different impact categories as they have been calculated within this packaging. Also broken down into different types of impact categories. CO2 equivalent is very commonly analyzed, but we can also show how that packaging performs across other environmental categories as well. Okay, so that is essentially the overview of different types of the graphs and tables. And then we can also jump into the actual report. As you can see, it's quite an extensive report. This is where it's all customized at the beginning with your own company name and logo and everything. And then it just goes through and explains what has been used within this model. So what types of packaging have we analyzed? What's been the unit of measurement? the assessment units, and then we're entering. It also shows all of the values that we've entered along the way within these fields. It gives a full overview of those results as well, according to different impact categories, but it's also very user-friendly in that it explains what the results actually mean in layman's terms. So it really sort of breaks it down for anybody to understand in terms of what is acidification, what is freshwater eutrophication, and what does that sort of mean if we actually make a change to those in those particular areas. We also have an option to calculate material circularity based on the Allen MacArthur methodology, and that is also possible to calculate what percentage or what is based on this scale from 0 to 1. How circular is that packaging type, particularly relevant for different recycling options as well. And essentially, that's the report. We have a breakdown of the entire packaging by different types of materials involved. And then at the end of the report, we also have an entire list of all those parameters that have been included and the values that you have entered along the way. This is particularly helpful if you want to repeat any of your results in the future. And then those results can be, that report can be saved and shared, and it also downloaded as an Excel file. So if you have already done some calculations, you can simply export these as Excel and import them into your other table that's already existing. Okay, well, thank you very much for your time. And with that, that concludes the presentation of the GaBi packaging calculator. Thank you very much.
Thank you all for joining our webinar, Lifecycle Assessment, Your Path to Sustainability. This was the third part of a series of 4 webinars. Recordings of this and previous webinars can be found on our homepages. Our last webinar will focus on the conceptual process design. PDC will wrap up the webinar series by walking us through the conceptual process design using their expert system called ProSyn and share results from the techno-economic assessment of the Impress concept. Stay up to date with the Impress website and social media channels. I see you next time.